we talked about proportions at some point last week then. To be similar again, all right, we said that they are two figures that have the same shape, but not necessarily the same size, okay? And that is what we said are to be uh, similar. So I guess we're just saying similar figures, all right? So these similar figures, all right, they could be, we could be talking about quadrilaterals, pentagons, hexagons, triangles, whatever the case might be. All right, those similar figures there. As long as they're two figures that have the same shape, but they don't necessarily have to be the same size, those are considered to be, again, similar. Now, in there, to be considered to be similar, the same shape, what's building that same shape is the corresponding angles. What's building that same shape, the corresponding angles have to be congruent, okay? So that's going to build that same shape, all right? Now there's, the next part with that is getting into the corresponding sides. Now, the corresponding sides have to be what we call is proportional, okay? Now, what do we mean by when we say the word proportional? So what we mean by the word proportional is, kind of shorten it down here. Proportional means all the sides are in the same ratio. Okay, give me a second to jot that down. So when I say all the sides are corresponding sides are proportional, what I mean by that is when we match up the corresponding sides, they all need to be reduced down to the same ratio. All those corresponding sides need to be reduced down to say 2 to 1. All sides come down to 2 to 1, 2 to 1, 2 to 1, or 3 to 4, 3 to 4, 3 to 4. If one side reduces down to 3 to 5, but the other three sides are 3 to 4, then it's not a similar figure. Okay. So in order to say that that figures are similar, these two things have to be happening: that the corresponding angles are congruent and the corresponding sides are proportional. If these two things are met, then we have ourselves similar figures. And that's what today's is going to be about then, is showing that we have similar figures. So today we're doing a little bit of proving here is, can we say that we have similar figures? If these two things happen, we say things are similar. If one of these things fails, then we don't have similar figures and we just say move on, okay? Now, we know our symbol for congruence. Our symbol for congruence is the equal sign, and above that equal sign is our squiggle there. All right, our similar figure. And if we take off the equal sign, that's just our figure for similar, okay? So that is our symbol for similar. Now let's just start off here with just making sure you can match up the corresponding pieces, which we've already started to do throughout this, throughout the year here and there, is matching up corresponding parts. But as we work through this next part, this topic into next topic with trig, we want to make sure you again keep matching up the corresponding pieces. And we've already started to do that back in the last topic with matching up the opposite angle with the opposite side. Okay, small, small, medium, medium, large, large, same idea there. So what we've done here is what we've written so far is, somebody's already stated that they've already done the work, and they've stated right up here, this is what we call a similarity statement. When you see a similarity statement, what that means is somebody who's already gone in and said the corresponding angles are congruent, the corresponding sides are proportional, these are similar figures. So what I want you to do is just take a minute off to the side there where it says complete each statement, match up the corresponding angles. Angle A, they said, is congruent to angle P. What goes with R, what goes with B, and complete the last two, what goes with what on the last blanks. So and match up the corresponding angles. So if you haven't done so yet, just do the angles. Shouldn't take you more than 10-15 seconds then to match them up. Okay? Just do the angles, don't need to do the sides yet. Now, as we'll see here, as we work throughout the next few days, these pictures will rotate on us, reflect on us, and sometimes it's a pain in the butt to say, keep track of visually what are the corresponding angles and sides, because when they rotate on us and reflect on us, they kind of almost look the same lengths and whatnot, so it's a pain in the butt to keep track of it. So look at the similarity statement. The order that the statement's written in matches up nicely with that. So myself, I don't always look at that picture. Sometimes it's easy to keep track of, but I usually read the similarity statement. The order that it's written in is exactly how you want to match it up. So as I look at A is congruent to P, first position, R is in what position? Third, so what's in the third position? C is, right? So I'm not even looking, say, at the picture itself. I'm reading that similarity statement. Angle B is in what position? Second, so what's in the second position? Look at the statement. The statement is probably your quickest route right there. And what is the last round then? Did we forget? D corresponds with S. Okay, that's not a D, is that? Try this again. Okay. Now, what they've written on the next round is the corresponding sides. Now, last week we had talked about an extended proportion, and this is what this is, an extended proportion. An extended proportion is where we are seeing this corresponding sides are turning out to be proportional. So if we had some actual numbers up here, we are finding out that these are all corresponding sides are all turning out to be the same ratio. So if we had some actual numbers of saying like this is 3 to 4, okay? All these sides would turn out to be 3 to 4, 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 something like that. Okay, they all reduce down to the same size. Okay, not quite the case, but we could go like that. So same deal. What goes with what? AB goes to PQ. They've already started that off with you. What goes with QR? What corresponds to QR? Somebody? BC. Again, I'm using the similarity statement, or you can look at the picture here. CD corresponds with what? And then what's the one that we have not stated yet? Yep, we did not state the bottom side. DA corresponds to, what did we say? SP. So as we state out these, this extended proportion here, that's what we're going to get ready to do in just a minute on the next round of examples. That when we go through and determine if figures are similar, we got to do these two things. We got to go through and check to see if all the corresponding angles are congruent. If they check out there, cool, that's the first thing. And then we got to see if this corresponding sides are proportional. If all the corresponding sides are proportional, then we have what? Similar figures. If at one time something fails in here, then we stop and we say we're not similar, and then we move on and we call it a day. So that's what we are doing here. Let's jump right into it, and let's do that first example there, number 2 then. That's our question for the day. Do we have polygons that are similar? And what we want to do then is first look at corresponding angles. That's usually the first thing that's probably quickest to do. And then we need to match up the corresponding sides and see if they are proportional. So let's talk about the corresponding angles. I know there's not necessarily a lot of room that you have there, but let's find some room and state out the corresponding angles first. Now I'm going to just do the corresponding angles over here. So are the angles, can you go walk it around and just do what we did up top there? Can you match up angle A on the other triangle with another corresponding angle? Yes, no? Yeah, angle A goes with what? D. Match it up, go at it. Match them all up. Angle D goes, sorry, we said angle A first, didn't we? Angle A goes with angle D. Keep going, match up the next angle. Okay, B goes with E. So we're watching the single angle, double angle markings with angle E. Can we do that with C? And that's not stellar. Let's try it again. And triple goes with F. Okay, check. We took care of the angles. Cool. Now we need to go on to the corresponding sides. So that's where usually it takes us the longest to make sure that you get the corresponding sides that are proportional. So I'm going to take that work on to the other side where maybe there's a little bit longer room there. Now we need to check to see if the sides are proportional. This is where the mistakes happen, where students are not matching up the right sides. Small, small, medium, medium, large, large. Pay attention to the angle markings as well. Just take your time of matching the corresponding pieces up. So I'm going to start off with that 7, okay? That 7 is between A and C. What is A and C corresponded to on the other one? Get that out of there. Yeah, 7 right there corresponding to D and F, right? 1, 3, 1, 3, D and F, 7 to 14, right? So what we need to then see is, what's that reduced down to? Is everything else reduced down to a half? If everything else reduces down to half, that checked out, that checks out, we are similar figures. If at any time something screws up, then we're not similar. Now at that point, if you're all smart enough, you can also do a quick look and see, oh yeah, 10 to 20 checks, 6 to 12 checks, and then we're good to go. But that's what we're doing when we say, are these proportional? What is it? 6 to 12? That's what we want to mean. That's what we mean by proportional. Are the corresponding sides proportional? That's what we mean. Are they all in the same ratio? And because that checks out, now we can finally answer our questions out. So do we have similar polygons? Yes, we do. If they are not similar, state why. So we would state why, what failed. When nothing failed, move on. If they are similar, we can then complete the similarity statement. So complete it. Triangle ABC. Walk it around, match up the corresponding pieces in that order. You just did that. When we said ABC, A went with D, B went with E, and C went with F. So triangle what? D, E, and F. And the similarity ratio, well, what's the similarity ratio, everybody? 1, 2. Right. The ratio is typically the order of the statement. So the statement was ABC to DEF then. That's usually the ratio as well. So what is it? 1/2. Okay. So however the statement's written is usually how the ratio is written as well. Okay. Because ABC was first, that's how what that ratio will then go. Okay. That's about as crazy as it gets. If you can match up those sides and angles, then you're good to go. If anything failed, tell me what failed. And then don't write the statement, don't write the ratio. You can only do those two things if you're similar. Okay? All right, let's go through another one. That's what we're doing here today. Let's go with the next one down below. We got ourselves a quadrilateral. In that quadrilateral, can we match up all the corresponding angles? Yes, no, maybe? Let's go match them up. On the angles, follow through, pick an angle. Angle M. Can angle M match up in the other triangle? Not triangle, it's not a triangle, is it? Can angle M match up in the other quadrilateral? Angle M appears to match up with angle what? W. Okay, let's keep going. Walk it around. Angle J. What's J here to go with? T, right? There you go. K appears to go with what? U. And what's the other one? L double marking, or sorry, that's triple markings. Appears to go with V. Okay, here's we got the same shape going, don't we? All right, let's go match up our corresponding sides. Doesn't matter which side you want to start off with. Just pick a side and just start walking it around there. Okay. I start off up there at M. I'm going to take that 6 right here. That's between the double and the single angle marking. And I'm going to pick up that 6. And what does that 6 correspond to in the other one? Single double goes with single W. Single and double. So MJ goes with WT. So 6 goes to 6, right? What's that reduced down to? That's a little odd, but we'll take it right now. So walk it around. So I take double and 90, which is 12. What's 12 correspond to? TU, which is? Now I'm looking for a 1, but what's 12 to 6 reduced to? Are we consistent? So what are we going to do? We're going to stop. Yep, we're going to stop and say nope, and we're done. Don't need to walk it around and do the other ones. As soon as one fails, you're done. And we're going to say, are the polygons similar? Nope. And tell me why. The corresponding sides, if I can spell that, the corresponding sides are not, let's use that fancy word there, proportional. And if you said not the same ratio, that'd be fine too. Okay? But you don't need to go walk it around and do the other ones. Now, if you walked it and did what? The other direction, I think you'd still find you would have screwed up at the same time the other direction too. Okay? Just depends on where you would have started off at. You might have chose poorly and kept finding that they kept working and working until the very end. But as soon as you find that ratio screws up, double check your work. Make sure you didn't match up anything correctly. But if you find that nothing is turning out to be in the same ratio, not proportional, then it's not similar. Okay. So angles, sides, got to be in agreement. Let's move it. Let's go with another one there. All right. How about the next one? Yeah. Quick. I'm on the next one. Let's match these up. Get our calculators there because I think we'll need maybe do just a little bit here. All right. Let's match up these angles. Can we match up these angles here? Okay, let's take that 90 degrees. That's the one that jumps out to me. Okay, angle N. What's angle N corresponding to? Angle Q. So far, so good. I see a 63 degrees of P. What does P correspond to? So far, so good. Now, we can use our 180 degrees, right? And what's that going to turn out to be? Angle 27, right? It's 27 degrees there, right? And that's 27 degrees at the same time there, right? So M does go to T correctly. So right out of room there. So far, so good on that, right? Angles, check out. Now what about the sides? So let's go to our ratios. Pick me a side, and then let's use our calculators. Okay? You don't have your calculators out? Let's get the calculators going. All right, somebody pick me a side here. What side do you want to go with? What side do you want to start off with? I just start with the hypotenuse. We all know the hypotenuse. Let's go there. What's the 2.2 start off with? 2.2 corresponds to what? 1.1. So go to your calculator and type that in and reduce that. You always reduce these fractions to compare your ratios. So what's 2.2 divided by 1.1? Reduces down to 2. Okay. So I'm looking for everything to have a ratio of 2. Go pick another side, match up the next corresponding sides. What's my next side you want to match up with? I'm going to take that 2. That's across from my 63. MN of 2. What's MN of 2 going to correspond to? 1, that's QT. That is across from 63 degrees. And 2 over 1 reduces to 2, right? So far, so good. And what's the one we haven't talked about yet? 1. And what's that 1 correspond to? So opposite 27. Opposite 27 is 0.5. And what's 1 divided by 0.5? It is 2. So, did everything check out right here? All right, so what do we have? All right, so let's circle it. And because they are similar, let's complete the statement. Now, on completing the statement here, you got to name it out. I don't care how you name that first triangle, whatever you want to name it, I don't care. I care about how you name the second one. So how do you want to name the first one? Triangle what? Okay. M, N, P are heard. That's fine. But whatever you name that first one, cool. But the second one is dependent on the first one. So if you went with M, I heard. What does M go with? T. N goes with, and P goes with what? Okay. Corresponding pieces need to go together. And what was the ratio then? Correct, 2 to 1 then. Because we start off with M and P with that first one, the order is, then the ratio is that first one to second one then. What did we just say? 2 to 1, 2 over 1. That is correct. Okay? All right. Let's go with the next one there. All right. On that next one, we can do a quick glance and determine, yeah, all the corresponding angles are congruent, correct? That's an easy one. How about the sides? On these sides here. Now on these sides, we've got small and medium, or small and large, I should say. We take the side of 10. What does the side of 10 correspond to? What's the side of 10 going to correspond to? It's a small of 10. So what's the small of the other one? 8. Yeah. So go with the small and large. Okay. So small of 10 is going to go with the small of 8. We'll reduce that down. And what's that reduced down to? What is that, 5/4? Okay, so I'm looking for a ratio of 5/4. So what's the other sides correspond to? 12/9. Reduce that by what? 3. And what's that reduced down to? 4/3. The angles are there, but the sides match up with that. Does that sides check out with that then or not? No, they do not. Okay, so we do not have that. And the reason what we can say that is, again, the corresponding sides are not proportional. Okay? So, don't answer everything else below that. Now, even just scratch it out. If you say no, then you can't answer those two things out. Okay? All right. Give you a second there to pause. That's our first step, is determining if similar figures are happening. If similar figures happen, then we have ourselves different shapes that we can, again, match everything up with, which then opens up our next part of the lessons for today. Setting up proportions, allowing us to find missing sides. And then Thursday, Friday, we're going to talk about some shortcuts, because that is a pain in the butt. Matching up all the angles, matching up all the sides, and as we'll find out later on, sometimes we don't have all that information, and we'll see that on Thursday, Friday. Now, number 3, let's do this. Number 3 now, we want to go through and find out actually some missing values. So on number 3 here, they are telling us they've already done the hard work for us. They give us a similarity statement, and what that similarity statement tells us is they've already done the work and said, somebody has already said these are already similar for us. Okay. Now what we want to do here is somehow figure out a way to find the values of X and P up there by knowing that these two triangles are similar. All right, let's do that. By knowing that these two triangles are similar, what we can do is create a proportion. We're all about proportions. When you see the word similar up there, think about proportions. when you look at these two triangles, what is a side that you know for sure in both of these triangles that kind of links it all together? What's a side that you know on both of these that kind of link it all together? The bottom one, right? The 5 and 9 is like your kind of your key, your legend that links it all together. So we're going to use that 5/9. That's like that ratio, that scale that we said like in map making that takes it one to the other. It's kind of that same idea. So that 5/9 is what we're going to use to help us find both P and X in just a minute here. Now, let's go find that P. What does that P correspond to? Now, we know that P corresponds to 6. When I put that P and that 6 in this proportion we're creating, where does the P go? Where does the 6 go? Because 5 is the numerator, P's got to correspond with that. Correct. And we've just been solving proportions for the last couple weeks. There you go. Cross products, 30 is equal to what? 9p. And what do we have? Divide by 9. It is not a nice number, is it? So we can reduce that, right? What's that reduced by? 3. Somebody got 10/3. That is not going to be a nice decimal. So we're always going to be then the reduced fraction. If it's a nice decimal, 0.5, 0.25, okay, that's fine. Terminating decimals we're okay with. But if it's not a nice fraction, always give me the reduced fraction. Sorry, nice decimal, give me the reduced fraction. Okay? Now, the next one. We still got to find x up there. What does x correspond to? X corresponds to what? 6. We're going to use that 5/9 all over again. 5/9 links us all together. Keep using it. Now, that x you just told me corresponds to that 6. Same deal though. Where does that 6 go at? The numerator or the denominator? Yeah. 5/9. 5 is with that 6 then. And it's 5 plus x. And all that work that we've been doing to get you up to speed of solving proportions comes into play right there. Cross products we go again. As we go with our cross products, you better put that 5 plus x in parentheses. Again, as I've said, as we've worked through things look a lot better with solving proportions than they were back at the beginning of the year, so I'm very pleased with that. As we distribute that on through, 25 plus 5x, and 9 times 6 is what? 54? Kind of running out of room there. 54 minus 25 is what? 29. And when you divide that divides nicely. Gives you a decimal, I mean, but nice decimal. 29 divided by 5 is what? Somebody get 5.8? Okay. 5.8. Now, on that one, every year I always have somebody suggest using Pythagorean theorem. Does anything up there tells me that was a right triangle? No. So nothing up there tells me that was a right triangle. Don't just assume it's a right triangle. Okay? But what allowed me to do everything there was right there, the similarity statement. When you see that similarity statement, you better think proportions. Okay? Let's go to the next one. They don't give me a similarity statement, but what they do tell me is we have similar triangles. So same deal happened. We have similar triangles. Let's go at it. Let's find x and y here on that. All right, finding x and y here, okay? Give me a second here. All right. So off that, how many triangles do we see up there? 2 triangles. Yeah, we have 2 triangles. Separate them out. We've done this before. We have 2 triangles up there. We have 2 triangles. That bottom one is not really a triangle. It's more of just a quadrilateral. But let's separate this out where we have the top triangle. I'm going to separate this out. And then I've got this bigger triangle. Okay. So on that top triangle, I've got an X and a Y, and I got a 5, don't I? Now on that top triangle, sorry, on that bigger triangle, what links do we have? I've got a 8, I've got a what? 6, and I got a 10. And because I have similar figures, similar triangles, what's the one side again I asked earlier on that first one? What's the one thing that kind of links it all together? What side kind of links it all together? The 5 and 10, right? Yeah, the 5 and 10 kind of links it all together. So I'm going to use that 5 and 10 to help me find X and Y then. So pick a variable and then go at it. What variable you want to find first? Pick a variable. Pick a variable.
X.
Thank you. X goes where? Numerator, denominator. And what does X correspond to? Okay, for the other variable Y, and Y corresponds to, so do your cross products. And on this particular one, why do I know this is a right triangle? What's that? It's a 3, 4, 5. How do I know it's a 3, 4, 5? Because it's 6, 8, 10. It's a 6, 8, 10 that's been it's been doubled, right? From a 3, 4, 5. So when you do your cross products and find these out, okay, this is just a 6, 8, 10. Divide that by 2, and this becomes what? 4 and 3 is what you should be getting here. When you solve these out, 3 here, and this is what? What did I just say? 4? Off of that. Okay. Now, if you notice it was a 3, 4, 5 in disguise, cool, more power to you. If you don't notice it was in disguise, because I didn't say anything until the end, we do our proportions, and there we go. Okay. All right, last one there, I think, and we'll call it a day. All right, last one there. How many triangles we got on the last one? 2. Separate them out. Okay. Separate them out. Help us find H off there. So we got this smaller triangle, and we can see this bigger triangle there. And the reason why we're going to do that, because at the very top there it says we have similar triangles again. We've got that small triangle. Yeah. 6 meters and what is it? 0.9 meters. And on that bigger triangle, what do we have? H meters is what we're trying to find. Now, what's the length of that bottom piece going to be? Right. Don't forget, we've done this before, just don't forget it, where sometimes we need to add those smaller segments together to get this larger leg, which is, in this case, 18 meters. And then just like I keep asking you, when we separate these pieces to create this proportion now, what is the side that links it all together? Those 2 bottom pieces, right? 6 to 18. Now I don't care really which one you put first, the numerator or denominator. 6 to 18. But 6 to 18 goes right there, or you can put 18 to 6. It does not matter. But whatever you start with 6 to 18 or 18 to 6, be consistent. What goes in the numerator then, and what goes in the denominator? 6 to 18 is going to be what over what? And if you want to 18 over 6, then you could have put h over 0.9. Okay? So finish it off now. Do your cross products. 6h. I'm running out of room there. And then 18 times 0.9. 18 times, what is it? 0.9. And then divide that by 6. And check me as well. Somebody get 2.7. 2.7 what? It's got units on there, so please include those units on there as well. Now this directions has one other thing they'd like us to do. Find the value of h did that. It also wants us to find the perimeter of triangle ADE. ADE is the big triangle. So we got the 2.7 meters. The perimeter, we need to walk it around and add it up. We are missing the hypotenuse. Everything goes back to Pythagorean theorem. So we need to do a quick Pythagorean theorem to help us find the hypotenuse. So let's go find that hypotenuse really quick. 18 squared plus 2.7 squared equals c squared. This is an old school problem now. So somebody check me out as well. So we go and finish this thing off here. 18 squared plus 2.7 squared. It doesn't say what to round, so we're just gonna go with the nearest tenth. That's kind of our default then. Somebody get 18.2 then? Meters. Okay, I heard somebody say 18.2. And then we can walk it around, and what's the final perimeter? 18 plus 2.7 plus 18.2. So we got about 38.9 meters. Okay. As you're going to see happens over the next about month as we roll into March, beginning of April, you're going to get back into some perimeter and area as well. We haven't touched it much of that lately, but that's going to roll back into us. Okay. So that's tonight. Tonight we're going to have some more work with that. Tomorrow we'll come in, we'll do some stuff with early dismissal. So don't forget it's the weird schedule. What is it? 6-5, and then 1, 2, 3, 4. And then I did not get key out there. I don't think I'll have time for that. And then Thursday, Friday, we'll talk about a shortcut on proving triangles similar. Right now, we have to take the long road there. I have to show all the angles are corresponding. All corresponding angles are congruent. And all the corresponding sides are proportional. I can show the shortcut on triangles. All about proportions here.